Alright, so this is going to go over topic 5, properties and changes. First, we're going to talk about elements, compounds, and mixtures. Just as a quick review, elements are pure substance. They cannot be simplified by physical or chemical changes. They are made of atoms. Every element has a unique number of protons. So elements are uniform throughout. You can have elements consist of a single atom, such as calcium, as a diatomic molecule like nitrogen, or as a group of multiple atoms, such as arsenic As4. As long as there is a single capital letter, it's representing one element, and you know that that is not able to be decomposed by chemical or physical means. Compounds are also considered a pure substance. They are uniform throughout, and they result from two or more elements being chemically combined together. You can break a compound down by chemical changes, such as decomposition, but you can't break it down by physical means. We'll talk about physical means a little bit more with mixtures. So compounds can consist of just two elements, like table salt, more than one atom of two elements, like water, or you could have more than two elements, such as sugar, and in sugar's case, you have multiple atoms of each element. Mixtures are going to have some variable composition because they are made of two or more pure substances. And so, like when you drink Kool-Aid, you have the Kool-Aid that's being added to the water, and you can separate the Kool-Aid solid from the water by evaporating the water away. You are not changing either the water or the Kool-Aid, but you are separating the two. And physical changes would result in a separation that would not change the substance's properties that were making up your mixture. Two ways we've talked about classifying mixtures previously are homogeneous or heterogeneous. Homogeneous would be like saline solution. You can't see the salt in the water, and it has the appearance of being uniform. While heterogeneous would be sandy water, because you can see the sand separate from the water. So some examples include wood, milk, and coffee. So physical changes, kind of like we just talked about a little bit before, result in a property being changed, but they do not cause the substance itself to be changed. So when you go through a phase change, you're changing from solid to liquid state, or a gas to a solid state, but you're not changing the actual substance, just the form in which it's being represented. Tearing would just be separating it out into smaller pieces, as would be crushing. Dissolving would be taking something that is typically a solid, maybe a liquid, and when you add it to, say, water, you're forming an aqueous solution, but it still has its properties. So if you add salt to water, you can remove salt from water. Chemical changes do result in something, a new substance being formed that has its own set of properties. So when wood is ignited and it burns, when it's finished, you no longer have the wood there. You have a lot of carbon and other byproducts. You have the vapors that have gone off into the atmosphere, and each of those substances has its own properties. Reacting with acids, any other sort of reaction would result in a chemical change. Okay, and by reaction, it has to be something that would take place. If it doesn't take place, it's not going to be considered a chemical change. So here, melting iron metal. Melting is a phase change, so that would be physical. Iron combusting with oxygen to form rust. You may be able to scrub the rust away, but once the iron has combusted with oxygen, you're not going to be able to get it back other than through a chemical change. And example 3, you have CO2 as a solid, you heat it, and now you're turning CO2 into a gas. It's still carbon dioxide, so it still is a physical change. This is what happens when dry ice sublimes, and because heat is on the reactant side, it is an endothermic change because heat is being added. In the 4th example, wood burning in air. When we just talked about how when you burn wood, it makes new substances, so this would be a chemical change. In example 5, we have H2O2 being turned into H2O, oxygen, and heat. This is what happens when you put hydrogen peroxide on a cut. You have made two new substances out of the original hydrogen peroxide, so this is a chemical change. Because heat is released in this process, it would be an exothermic change. Finally, breaking a crystal apart into small pieces. The crystal still has its properties. They're just now into smaller pieces of that crystal. It still would have the same hardness, the same color, things like that. So those would be considered a physical change. All right, and then the last part we're going to talk about are properties. Physical properties, they can change for a particular substance, but they won't cause the substance to change into something new when they are changed. So like density will vary depending on what temperature you're at, things like that. You can have physical properties that are both qualitative and quantitative. Qualitative is describing a quality, a characteristic of it. Those of you who know me know I have red hair. That would be a qualitative observation. A quantitative observation is something numerical. So if you wanted to measure the length of my hair, that would be a numerical observation. It would have a unit attached to it, and that would be quantitative. Two other words that we can use to describe properties are intensive and extensive. Intensive is something that it doesn't matter how much of the substance you have, it's always going to have that same value. So if you are at 25 degrees, water will always have a density of 0.998 grams per milliliter, whether you have a cup of it or whether you have a whole beaker of it. Melting point follows along those lines as well. Extensive does depend on how much of the substance you have, such as its mass, such as its length, such as the amount of energy it takes for it to undergo a change. So intensive is independent, extensive is dependent. And I've given you some examples. Hopefully these look familiar. Odor, color, volume, state, density, conductivity, the ability to conduct electricity, melting boiling point, malleability, easily shaped, or the ability to be shaped, ductility, to be drawn into a thin wire, solubility, the amount that can be dissolved in a certain amount of water, depending on the temperature you're at, and specific heat capacity, the amount of energy it takes for a substance to go up in temperature by 1 degree for every gram or mole, depending on the units you're using. A chemical property goes hand in hand with chemical change. It's the ability of a substance to go through a change, or in some cases not to go through a change, telling you what it will react with and what it won't. So burning, rusting, digesting, growing. Our first example here is the boiling point of an alcohol is 78 degrees Celsius. All we're doing is changing the alcohol from a liquid to a gas, so that would be a physical property. Number two, sugar ferments to form alcohol. Sugar has its own properties. It's undergone fermentation to make alcohol, which has its unique set of properties. That would be a chemical property. I'm sorry, I added that in up here. This physical property is quantitative because there is a numeric number associated with it. I'm not going to ask you to do a whole lot with quantitative and qualitative with chemical properties. For the most part, those are just going to be qualitative. But with physical properties, I just wanted to kind of introduce that terminology or review it with you more. Example 3, a metal wire conducts an electric current. When you conduct a current, you are not changing the wire. Otherwise, we'd have to replace the wiring at school and at our homes and at our workplaces all the time. So that would be a physical property. There is no number associated with it. So therefore, it is a quality, an observation about it, and is qualitative in nature. Both of these properties would be intensive as well. An extensive property would be the volume of the alcohol or the length of the wire. And an example 4, platinum does not react with oxygen at room temperature. This is showing the lack of a chemical reaction, telling you what it does and doesn't react with. So that too would be a chemical property. All right, and hopefully this will help you with part 5 of your review assignment.